Hello all. In today's lecture, we'll be solving some few problems based on combinational logic circuit, and we'll see how to design the combinational logic circuit also for those problems. Clear? In our previous lecture on the intro of combinational logic circuit, we studied about the characteristics and the design procedure, right? That design procedure, whatever we read there, we are going to implement it here. What was the first step? It was mentioned that your problem in your combinational circuit will be given in the form of statement, right? Here, this is your statement. From this statement, what is the second point? You have to identify what is the input variable and what is your output variable. Now, divide this into portions and then try to understand the question very clearly. Go step by step. Design a combinational logic circuit. They have asked you to design. Design meaning finally they are expecting a logical diagram. They are asking you to implement in the form of a logical diagram. That is the meaning for the word design. Fine. Now, design a combinational logic circuit with 3 input. How many inputs you have? They have mentioned 3 input. So, draw the truth table. How many inputs are there? You have got 3 inputs. This is my input and this is my output. Fine. 3 input. I have taken the variables for 3 input as A, B, C. Clear? Now, that will produce a logical 1 at the output. Before that, for 3 input, how many combinations can be there? 2 power 3, that is equal to 8 combinations we can get. That is 0 to 7. You can get 8 combinations. Write down the combinations first. It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These are my 8 combinations for a 3 variable. Give the equivalent decimal. It is 0, 1, 2, 3, 4, 5, 6 and 7. Right? Now, coming back to the question. The circuit with 3 input. 3 input we have written here. That will produce a logical 1 at the output when it will produce a logical 1 at the output. Meaning your output wherever 1 is there, we have to consider that only. But what is the output? That they have not given it directly. They have given a clue for you there. When more than 1 input variable is at logic 1. This is the clue. This is the clue for finding your output. What is the output? When you have more than 1 input variable at logical 1. Wherever you have more than 1 time the occurrence of 1. Then those numbers alone you have to take, and those numbers, for those numbers alone you will be having your output as logical 1. That is what they are mentioning. This will produce a logical 1 at the output when more than 1 input variable. These are my input variables, right? When you have more than 1 input variable is at logical 1. Here, check on the number 0. Is it having 1? No, it doesn't have 1. So the output for it is 0. Here, do you have 1 here? Yes, you have only 1. They have mentioned like more than 1. They have not mentioned like more than or equal to 1. Right? So wherever you find more than 1 time the occurrence of 1, only those numbers you have to take. Here you have only single occurrence of 1. So the output of it will be 0. For this number again, you have only single occurrence of 1. So this again will be 0. Here you have 2 occurrences of the number 1. Right? So the output will be 1. When you have more than 1 input variable at the logical 1. Here this variable is at logical 1, more than 1 input variable. So there you have more than 1 input variable which has got a logical 1. So if this is the case, then your output will be 1. Is it clear? Now check on the number 4. There is only 1 time the occurrence of 1. So it will be 0. Check on the number 5. Here you have 1. There is one more 1. That is 2 times the occurrences of 1 has come. So the output will be 1. Here again 2 times occurrence of 1. So output will be 1. Here 3 times occurrence of 1. So the output will be 1. Understood how to find the input variable and how to find the output variable? Is it clear how to do the mapping and all? In your exam point of view, they will be giving only the statements. From the statement, you have to divide the statement step by step and then you have to understand clearly what has been given in the question. 3 input, so you will be using 3 variable input. For 3 input, how many combinations are there? Write down all those combinations. Fine. Now, after this, go to the next half of the question. Here they have mentioned like you will be getting a logical 1 at the output when more than 1 input variable is at logical 1. Fine. What does it mean? If you have more number of occurrences of 1, then only for those numbers you will be having your output as 1. Greater than. The number of occurrences of 1 should be greater than 1. 1, it has to be greater than 1. Here, the occurrences of 1 is only one time. So, one time it is 0. They have mentioned like only greater than, more than. They have not mentioned like more than or equal to. If they have given more than or equal to, for these numbers also you would have mentioned 1. But they have not mentioned this. They have mentioned only more than 1 input. So, wherever you have more number of 1s, only those numbers you will be having a logic at the 1. Is it clear? So, what is your next step? Your next step is, after finding the input and the output variable, whatever values you have got in the output, you have to take it to the K-map. How many variable K-map you will be drawing? You have got 3 input variables, so you will be drawing a 3 variable K-map. Let me write the variables also, so that it will be easy for you to write the equation. Where this is an SOP, default it is SOP. Fine. Wherever 0 is there in SOP, wherever actual variable is given, you will be giving 1. Wherever the complemented variable is there, you will be mentioning that with 0. That is how you will be writing the midterms. Here both are actual variable. The first variable corresponds to, the first number corresponds to the variable B, and the second numbers are these. All the second number corresponds to the variable C. Fine? Now, it is B and C, this B and C bar. Clear? By now you should be able to solve your K-map and writing all these variables on your own. If you are still not confident in writing the K-map, refer to my K-map lecture, so that you will have a clear understanding and you will have a strong base with how to do the mapping and how to derive the equation using a K-map. Fine? Those who have not seen that lecture, I will give the link of it in the description. Please refer to it. Fine? Now, wherever you have the value 1 in the output, in that corresponding decimal numbers, you have to mention a 1 in the K-map. Clear? Here, where do you have a 1? You have 1 in the number 3. So, against 3, put a 1. Then, where's the next one? Here, you have a 1 in the number 5. So, against 5, you put a 1. Here, for the number 6 and for the number 7, you have 1. So, only on those numbers, you will be mentioning a 1. Is it clear? Now, do the mapping. Fine. What is the expression for this? This is f of a comma b comma c is equal to, give me the expression. It is a, and for this bubble on the horizontal, what is the equation? It is c. First term it is varying. Here it is b bar, here it is b. First variable is varying, so I cannot write. The second variable alone is common, so I will be writing c. Now, for this bubble, here on the vertical, both are varying. Here it is a bar, here it is a. It is varying. So I cannot include that. I will be including only these two variables. That is b and c. And coming to this particular bubble. For this particular bubble, on vertical it is a, and on the horizontal, which is common, first variable. First variable is b and b common. Second is c and c bar, which is not common. So I will be taking only the first variable. Clear? This is my simplified Boolean expression for the given statement. But I am not done with the answer yet. What have they asked? They have asked you to design a combinational logic circuit. So whatever equation that you have got, you have to implement. You have to design the circuit. How will you design? How many variables are there? 3 variables. You very well know, for designing you will be using only the logic gates, and what the logic gate is, what are the different type of logic gate, and what is the symbol for each logic gate, what is the formula for it. For detailed description of what a logic gate is, kindly refer to that lecture, so that it will be easy for you when it comes to designing the combinational circuit here. I'll give the link of that again in the description. Fine. A and C. A and C, it is product. So for product term, which gate you will be using? You will be using AND gate. A and C are my inputs to this particular AND gate. A and C, it is a product term. So let me write it here. For product term, you will be using AND gate. For sum term, you will be using OR gate. Fine. Keep this in mind. Now, A and B is a product term, right? For product, which gate you will be using? AND gate. So, this is the symbol for an AND gate. Clear? What is the output of it? It will be a product of both my input variables. Whatever input variable is being given to this particular gate, the output of that will be the product of your input. Is that clear? So first term we are done. Second term. The second term, it is BC. BC is again a product term. So for product term, I'll be using an AND gate. B and C are the input for this gate, and I'm taking it to a product, I'm taking it to an AND gate, and the output of this AND gate is going to be the product of my input, which is B and C. Is it clear? What is the third gate? It is A and B. So A and B. These two are again a product term, so I've taken it to an AND gate. The output of this gate will be AB. All these product terms, all these min terms are being summed up. Right? You have got a sum. You have summed up this min term with this min term, this min term with this min term. Right? So the output of all these three gates, you have to take it and then you have to send it to an OR gate. What is OR gate? OR gate is a sum gate. So this will be my final. So this is how you will be designing a combinational logic circuit using gates for the given statement. Is it clear? Let's sum it up. Whatever the question has been given to you, read the question carefully and very slowly and try to split the question into segments. Read it out. Design a combinational logic circuit. Design meaning they're asking for the circuit diagram. Is it clear? Now, with three inputs, how many they have given? 3 inputs. So, let me take my input. Draw the truth table. How many inputs? Mention those inputs with the different variables. 3 input combinations you have? You have the formula. For 3 input, it is 2 power 3, that is 8. And the combinations are from 0 to 7. Right? So, give the equivalent binary numbers for all the combinations. Clear? So, your input is done. Now, coming to the output. Read the remaining half of the question. So, the 3 input, that will produce a logical 1 at the output. It will produce a logical 1 at the output when more than one input variable is at logic 1. When more than one input variable is at logic 1. What does it mean? Wherever you find more than one time the occurrence of 1 is there, only for those numbers you will be having a logic 1 and the remaining numbers will be 0. Clear? That is how you have filled the truth table. After filling the truth table, whatever output you have, those output you have to take it to the K-map. You're not supposed to take the input variable. You have to take only the output variable. Clear? Take the output variable to a K-map. Wherever 1 is there, only those numbers you have to map it in the K-map and then do the mapping, take out the expression. This will be my final simplified Boolean expression. And this Boolean expression, whatever you have got it, try to implement that. Try to design it using the logic gates. Clear? This is how you will be designing a final combinational logic circuit for a given statement. Is it clear? I hope you're clear with this lecture. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.